actually planted on this wall, you know, and it's so historical and it's so amazing. It's like we're really there and we're walking up the wall.
I really enjoyed the opportunity to share aspects of my culture and learn about life in China. One of the best ways to experience another culture is to talk to people from other parts of the world and get to know them.
We all have the same goals in mind, and that is to educate our students, expand their minds, and become worldwide leaders in the community. We can do this, and we can extend outside the classroom.
I really consider myself very fortunate for the opportunity to visit China. I saw great and wonderful things, but most importantly, I made new friends. Well, that's it for now. Back to you, Dale and Joanna.
One day in the city of Dallas. 516,000 alarm clocks wake up the city. Millions of cars commute to work, and 2,500 planes take to the sky. One day in the Dallas Independent School District, a masterpiece is perfected. Records are broken. New worlds are explored. And the promise of tomorrow becomes a reality. Think you know DISD? Think again.
What's up, you guys? My name is Bill, and we're where it all happens behind the scenes of Calculus Live. Thanks for tuning in for today's show. But before we get started, we just want to cover a few ground rules. So let's head over to my man Ivan for more.
Good luck on your problem. Okay, ground rules. Let's see. You have to call in. Pick up the phone, give us a dial, give us a ring. I mean, we really want to hear from you. The number to call is 972-925-3123. Take a picture, write it down, just give us a call.
Number 2, when you do call in, step away from the television. It really hurts our ears and it sends off a really bad tone. See what I mean? So, when you call in, step away from the television. I thank you, our host thank you, and our ears definitely thank you. And another thing, when calling into the show, please do not use cell phones. Cell phones do not work too well with our audio system here in the studio. They give off a really bad signal and we have a hard time hearing what you're saying. So remember, no cell phones. Another thing that we want all of you out there watching to know is that you could be on TV. That's right, your face could be on the tube. Send us a picture, whether it be an individual photo or a photo of your entire class. We'd love to see you, and so would everyone else out there watching. Either mail it to us through Interdepartmental Mail at DISD Box 379 or drop us a line at calculuslive@dallasisd.org. Okay, well, it seems like it's just about time for the show to get started, so I have to say goodbye for now. But don't forget to call in for your chance to win all sorts of cool prizes. So get set for our all-new edition of Calculus Live.
Welcome to Calculus Live. I'm your host, June Harmon. call in problems together. Let's meet my student assistant for today.
Hi, my name is Gloria Medina. I am in Ms. Johnson's BC Calculus class, and I plan to attend the University of Texas at Austin next fall,
And what school are you going to be in?
the business.
That is very prestigious. Gloria, you want to go ahead and remind them about the rules, although the guys did a great job before the show.
Avoid using feedback, using the telephone in the classroom. Cell phones do not work. Turn down the set a little when you are on the air and sit back and relax.
We are counting down until the AP Calculus exam on May 11th. Gloria, how many days? We got to get right to work. Who's our first caller?
Our first caller is Giselle from Molina.
Hi. Giselle? Hello. I understand Ms. Brzezinski has everybody call once. Is that true?
Yes.
I think that's terrific. So today's your turn, right?
Yes.
Excellent. Well, Giselle, are you ready for a problem?
Excuse me?
Are you ready for a problem?
Yes.
Okay, let's go for it. The function f of x equals x cubed minus 6x squared plus 9x minus 4. Can you find the local maximum at x equals what?
Okay, first we have to take a derivative.
That's exactly right.
So it's f prime of x equals 3x squared minus 12x plus 9.
That is great. Now what?
Now set it equal to 0.
Good job. Then what?
You can pull out a 3.
I like that. I like to do that. All right, let me set equal to 0 and pull out a 3. Tell me what to write.
X squared minus 4x plus 3.
Perfect. Now what?
Now you have to factor.
Okay. How are your factoring skills?
They're pretty good, I guess.
Excellent. How about if I write the x and the x, because that's easy. You write the hard part.
Okay. Minus 1 and minus 3.
Perfect. You thought about it, you changed your mind, you did a good job. All right, now what do I do with this information?
You set it equal to 0.
All right, x minus 1 equals 0, and x minus 3 equals 0. And now what?
X equals 1.
Oh.
And?
And x equals 3.
Perfect. And what do I do with that information?
Now you have to do the number line.
Good, I like a number line. What do you want me to put on it?
You want to put F on the top, F and F prime.
Okay. That's right. That's fine. What else?
Okay, now put your numbers 1 and 3.
Okay. And now what?
Now plug it in.
That's right. We're going to check in between. These are the critical numbers, right? One might be a max, one might be a min. We don't know yet. So I'm going back to the factored form. What do you want to plug in over here?
0.
I like 0. That gives you negative times negative, which is?
Positive.
Functions going, oh, I did it wrong. I'm sorry. Positive down here, functions going up. When you plug in between 1 and 3, what do you get?
A 2.
A 2 works for me. Positive times?
Negative.
Functions going down. I know, I'm doing that. This is backwards day, isn't it? And greater than 3, what do you plug in?
Just any positive number. A million.
A million sounds good to me. That gives you what?
Positive.
Positive functions going up, going down. We can even see it, can't we? Well, your question was the local max. So which of these is the local max?
The 1.
At 1. So at x equals 1, the function has the local max. True? You did a good job. Excellent. Give her the bell for that one. Good job. You guys call back.
Okay.
Thank you.
Our next caller is Hassan from Carter.
Hassan? Carter?
How you doing?
Hi, is this Hassan?
Yes, ma'am.
How are you today?
Doing great.
How's Miss Blackwell?
She's doing good.
Is she? Excellent. I'm glad to hear that. Anything going on at Carter? Any big news?
Hello, everybody.
No, not really.
Say,
No, not really.
not really. Sometimes no news is
Just
good.
calculus.
Just calculus. Well, what else is there, right? Are you an AB student?
Yes, ma'am.
Okay. Have you studied E's?
E's,
2.7, 18, 28. Okay. Here we go. You don't have to know that, do you? All right. Got a problem for you here. You ready?
Yes, ma'am.
F of x equals 3x times e to the x. Find f prime of x, and then talk to me about the intervals of increasing, decreasing. Do you know how to find f prime of x for this problem?
Yes, ma'am.
What do you need to do?
To use the product rule first.
All right. Tell me what your product rule is.
It's going to be u prime v plus v prime u.
I think that looks perfectly okay. And so, what do you want me to write?
I have 3x. I mean 3.
3.
3 times e to the x
Okay.
plus e to the x. 3x times 3x.
That sounds exactly right. Now, would you factor something out for me?
You can take that e to the x out.
Anything else?
3.
Perfect. And then what does that give you?
1 plus x.
That is beautiful. You have found the first derivative. Now, talk to me about e to the x. Do you know what that looks like? Anything about it?
It's always positive.
Very good. It's always positive. So what's the only one you're going to set equal to 0?
1 plus x.
All right. I'll set it equal to 0, and you tell me what that means.
X equals -1.
Now, what do you want to do next?
Put it on the sign chart.
I like a sign chart. How do you label your sign chart?
F on the top and F prime on the bottom.
Okay. And then I'll put the -1 for you, and tell me what to do.
You're going to plug a number in before -1 into your F prime function.
All right. What will that be? What number do you like?
0.
This one over here, 0's good with me. Yeah, that's fine. We'll go over here and do 0.
Okay, 0 on the right and -2 on the left.
Okay. When I plug 0 in, what do I get? Positive or negative?
You get a positive.
Function's going up. Oh, I did it backwards, didn't I? This is my backwards day. I put those backwards. Can I change it to F prime and F?
Switch it, yeah.
Yeah, I'm sorry. All right, now when you plug in -2, what do you get?
You get negative.
Function's going down, right?
Yes, ma'am.
Tell me the interval over which the function is increasing.
It's negative. -1 to positive infinity.
Good job. And I like to put parentheses. What do you put?
Okay.
Is that okay with you?
That's good.
You're easygoing, right? Flexible?
Yes,
I
ma'am.
like to put the parentheses on that. That's very good. And the decreasing. So is this what can you tell me about this point? It's a what?
It's minimum.
It's a minimum. Is it an absolute minimum?
It's an absolute minimum.
It sure is, because the function's going down and then going up. Now, what would I say to get credit? I would say the first derivative is...
The first derivative is decreasing.
The first derivative is negative.
It's negative.
Followed by
Positive.
positive. At that point, that's got to be the absolute min, does it?
Yes, ma'am.
Excellent. You get the bell and the card for that one. Thank you very much, Gloria. Good job. Gloria, who's our next caller?
Our next caller is Christian from Adamson.
Hey, Christian.
Hi.
Hi, how are you? I heard one of the presenters, you know what they told me about the Adamson calculus students?
What did they say?
They said they already knew everything. That's what this presenter said. Huh?
It's because we're smart.
It's because you're what?
Smart.
The presenter said, you know what? They already knew it all, so I just put them to work demonstrating problems. That's cool? A cool thing to say, wasn't it? And a true thing to say. You gonna get 5s, all of you?
Probably.
Probably all of you 5s, yeah? All right, let's talk.
We can say like we're gonna get it because then if we don't get it, then they're gonna start laughing at us.
Oh, well, you know what? I like a positive attitude, though. Don't you? If you don't think you could, yeah, I hear what you're saying. You're being humble. That's a good thing. Being humble is good.
Back to work. Back to
But
work.
I believe from what I'm hearing,
Work,
you girls are going to do a great job. Okay, here we go. Got a problem for you.
Okay.
All right. A curve has a slope of 5x minus 1 at every point. What did I just tell you? This is the slope finder. What is it?
It's a derivative.
That's right, it's the derivative. Write an equation for this curve. In other words, I want y equals if it passes through the point 1, 3. Do you know what to do?
Okay, I need to find the slope for that point. Wait, they give us the derivative, so we just
All right.
put the one on the...
This is dy dx.
Exactly.
Now, this is the derivative right here, okay? Let me write this for you because I think there was some static and I didn't quite hear everything you said. So let me see. We need to solve for y equals. And then this is going to be our point that it goes through.
We just need the slope.
So we've got to separate the variables. This is the slope finder, okay?
Okay.
Okay? And so we're going to separate the variables. Have you done this before?
Yes.
All right. Oh, old hat, right? All right. Now, we're going to separate the variables, and we're going to find the name of the curve, which is going to be y equals something. Okay. Tell me what to do.
Okay, we're gonna take the integral.
Excellent. Keep going.
Okay, it's gonna be y equals 5x squared divided by 2
Perfect.
minus x plus c.
That is beautiful. Do you have a known ordered pair?
Yes.
Of course you do. They had to give you that, didn't they? What do I need to write?
Okay, 3 equal 5 half times 1 minus 1 plus c.
Perfect. Can we clean that up?
Yes.
Okay. 3 equals, what's 5 halves minus 1?
3 halves.
3 halves is perfect, plus c. Now, can you finish it?
Yes. It's gonna be c equals 3 halves.
Yeah, that's kind of like a trick question, isn't it? Let me go back and rewrite y equals. Tell me what to write.
5 over 2 x squared minus x plus 3 halves.
Perfect. And then if I said find y when x is some other number, you could do it, right?
Yes.
You did a great job. This is really a separate the variables problem. It's the easy kind, isn't it, when you don't have to do much separating. But that's not an easy problem, is it? You had to track through all the steps. You did a great job. Hey, you guys keep working hard. Keep aiming for that 5, okay?
Okay.
I'm gonna be anxious to see your results.
Okay.
Bye-bye. Who's our next caller?
Our next caller is Chris from Skyline.
Yeah, say.
Hey, Chris.
Woo! Hey, Chris.
How you doing?
Yeah, say hi to Gloria.
Hey, Chris. Good.
Glad Skyline's calling in. Well, Skyline's in the booth too, right?
Yeah.
Did you see that thing at the front?
Huh?
Did you see the video at the front?
Oh, yes, I did.
Wasn't that good?
It was.
That looked nice. Okay, you ready for a problem?
I'm ready.
Yeah, baby.
This is a set of some information about x and the derivative, okay? It's x and the derivative. The derivative has exactly 2 zeros. Can you see them?
Yes, ma'am.
Exactly 2, no more. Selected values are given if the domain is from over here to over here, okay? Then the function is increasing over what interval?
Over the interval from -4 to -2, I'm sorry.
Perfect.
And then from 3 to 4.
That's good. That's a perfect job. You know what? That was on a release test, and a lot of people missed that. How did you know to do that? How did you know what to look for?
You just look for when the derivative is positive.
That's
you know
right.
your function is increased.
That's right. And because they told us there were exactly 2 zeros, normally we have to worry that it's going up and down, right?
Right.
But because they said exactly 2 zeros, then that meant positive derivative followed by negative. Could you tell me where the function has max?
As a max?
Uh-huh.
Yes, I could.
Where?
And -2.
Yeah, good job. Because the derivative is positive followed by?
A negative.
There you go. That is beautiful. Hey, good job. You
Thank
keep
you.
up the good work. You guys call back. Who's our next caller?
Our next caller is Edgar from Sunset.
What number are you? What's your picture number?
4.
We'll get it ready in just a moment, okay?
All right.
How's everybody at Sunset?
We're doing good!
You're doing good? Hello, everybody. Excellent. I'm glad to hear that. Have you talked about velocity and particle motion? Sort of.
No.
No?
No.
You just pretending, huh? All right, let me show your picture first, okay?
No, you don't go do that.
All right, Edgar, there we go. There you are. Excellent. Show the one on the top. There's the one on the top. That person looks very familiar. I'm trying to think. Have we met? I'm kidding. All right, here we go. Given t is t squared minus 4 for all t greater than 0. Here's my question. Is the particle speeding up or slowing down at time 1? What all do you need to know to work that problem?
You need to integrate?
Do you integrate?
Yeah.
Let's think just a minute. If I want to know about speeding up and slowing down, I need the velocity and I need the acceleration, because that together, that'll tell me, okay? Can you find the velocity at 1?
Yeah.
All right, what is it?
Plug it in.
Yeah, just plug it in right here.
All right.
What do you get?
One squared.
1 squared. Take away 4.
-3.
-3, that's your velocity. Now let's do your acceleration. Well, how do you get acceleration from velocity?
Derivative.
And that would be
2t.
2t. And so what is the acceleration?
2.
2. If you have a negative velocity and a positive acceleration, have y'all talked about speeding up and slowing down?
Speed it down.
All right, if I've got a positive velocity and a positive acceleration, I'm speeding up, true?
Yeah.
I'm going 45 miles an hour, I add 5. I'm going, whatever I said, 50 miles an hour, right?
Uh-huh.
If I have negative velocity and negative acceleration, let's say I'm going -40 and I accelerate -5. I'm going -45. Did I speed up?
Yeah.
I sure did. If the signs are alike, I've speeded up. Now this is just direction, right? I'm driving to Fort Worth instead of to Dallas. It's a direction issue. If there's one of each, one of my students said they're working against each other. My velocity is negative, but my acceleration's pushing back positive. Am I speeding up or slowing down?
Slowing down.
I'm slowing down. Do you like that? I like that.
I guess so.
I like that. I don't live in negative velocity world, but if I think of it this way, -40, accelerate -5, oh, I've speeded up. Okay?
Okay.
So this one was slowing down. Hey, you did a good job. Thank you.
Here's Chris's picture from earlier.
There we go. Give the bell. We got to show Chris's picture from earlier, okay? Can we show Chris from earlier? We didn't get his picture on. Here we go. Chris? Sorry, we didn't get
You look pretty cool.
I like your attitude. There's a calculus attitude going on. Who's our next caller?
Our next caller is Antonius from Carter
Hey, Carter.
It's Antari.
and Taurus.
Hey, Antares.
How you doing?
I'm fine. How are you?
Fine.
You're doing well?
Yes.
Good. So still no news at Carter?
Nah, just calculus.
Just calculus. That's all you need, isn't it? How are you with implicit differentiation? Is that like your favorite thing? Whoops, sorry, I didn't get my scope ready. There we go.
That look pretty.
Does that look good?
Yeah, that look real pretty.
Yeah, it does, doesn't it?
Yeah.
I can tell you're a calculus person. All right, would you consider the curve defined by that, miss? Find dy dx. Would you tell me what to do? Say it again. Did I miss it?
6y squared.
6y squared.
Yes.
What do I need beside it?
Okay.
What else do I need?
dy over dx.
That's exactly right. dy dx. Okay, keep going. You're doing great.
Plus,
How do you like to do that kind of problem where it's blended up?
use the product rule.
It's a product rule. So what do you want me to write?
12x.
12xy,
No.
the derivative of this with y,
Yeah.
plus
Plus
this
that.
with the derivative of y,
y
right?
over dx.
Yeah. Did we get that right? Let's be sure. The derivative of the first times the second plus the derivative the second time. I think we got that right, whether I said it right or not,
Yeah,
okay?
that's
Okay, good. Lori's going to check us and make sure we got it right. Okay, keep going. What's next? I'm going to go down below because I've kind of run out of room.
Minus 24x.
Minus 24x
Plus 6 dy dx.
plus 6 dy dx equals
0.
Nothing. Good job. Now, what do I need to keep on the left, and what do I need to shift to the right?
Okay, keep the terms with deal y will give x on the left.
Okay.
Take terms without it on the right.
All right, let's see, 6y squared plus 6x squared plus 6. All of those had a dy dx. I'm just saving a little room on this one. Did I get all of them? And then what gets shipped over? Tell me what to write.
Negative 24x.
Now, if it's shipped over,
24x
24x
plus 12xy.
plus,
Minus 12xy.
there you go, minus 12xy. That's right. What's your last step?
And then you divide it.
That's right. What do you want me to divide?
6y squared plus 6x squared plus 6. Yeah, you can take out 6.
And I could take out 6. What else could I take out? 12x. I could do a lot of things, couldn't I, to make it look like their answer. Say it again?
You can do whatever you want to.
Exactly. If they don't make me go any further, I might want to stop here. But if I had to, like you pointed out some great things we could do to change the look of it. Hey, thank you for calling. You did a great job. That's a bell if I ever saw one. Who's our next caller, Gloria?
Our next caller is Mari from B8.
Hey, Brian Adams.
Hi.
Hi. What's your name again?
Molly.
Have y'all moved yet?
Not yet. We're in the process.
Oh, are y'all helping Ms. Arthur?
Sort of.
Good. You should help Ms. Arthur. Okay, I've got a question for you. Ready? Now, we're going to do 2, so this is for fun, okay?
Okay.
All right, one of my colleagues wanted me to use this on the show.
Okay.
Integral of 3x squared dx from 0 to ice. What do you get?
I get 3x
What is this?
cubed divided by 3.
You get 3x cubed divided by 3, so you get x to the third.
Yes.
And when you plug in, what do you get?
I.
That's right. You get ice what?
Ice cubed minus ice 0 cubed.
Get it? Ice cube, right?
Right.
Isn't that good?
Mm-hmm.
Do you like that?
Yeah.
I have 2 more, but I'm going to save them because, we don't want to use up all the good stuff at once. All right, here we go. Now I've got your real problem. That was just for fun.
Okay.
Here's your real problem.
Wow.
F of
Okay.
x equals, don't panic, e to the blah, 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 right?
Yeah.
Then f of x has a local minimum at, well, you need to do what?
Find the derivative.
Okay, let's do that and just see how it works, okay? So what is the derivative, Molly?
It's e to the x cubed. It's that whole thing up there.
Thank you. I'll write that whole thing up there for you.
Okay.
Times.
Times the derivative of that.
And what is that?
3x squared minus 4x minus 4.
Okay. Now that's the derivative, and you're going to set it equal to 0. Does e to the whatever go to 0?
No.
No, it's always positive. So that we can ignore, can't we? So once we've done that part, this looked kind of scary, but we can ignore it. So what do I need to set equal to 0?
3x, the derivative.
That's right, the part where I did the du. All right, tell me what to do. I'm looking for a local minimum where it occurs.
Okay. Can it be factored?
All right, let's see. I think that's exactly what you want to be asking. How about 3x and x? And now see if we can figure out anything else.
Would it be 2?
Okay, 2 and 2 sound good. And now we know there's one sign of each, and there needs to be more negative than positive. So where do you want the minus?
How about the 3x? No, the other one. Sorry.
That's okay. Let's see if that works. Minus 6 and plus 2, bingo. You got it right. And if you did it wrong, you just change it, wouldn't you? That's what erasers are for. All right, tell me what the zeros are.
There is 2. There's one at 2.
Uh-huh.
And then there's one at negative 2/3.
Perfect. I'll draw. Do you do number line? Is that what you do?
Yes.
I'd rather on this one, I wouldn't want to do anything. I wouldn't want to do a second derivative test, would you?
No.
No. Negative 2/3 and 2. Where do you put f and f prime?
I put f prime at the top.
F prime at the top,
And then
f at the bottom. Okay. I'll try to do it right. I've done it wrong 3 times today. Okay. And now, what do you want to use to plug in? This is my factored form. Where do you want to start? Over here?
I want to start with the 0.
I like the 0 too. What do you get?
2, hold on. 2?
Well, you get 0 and 0, you get negative something. We don't really care as long as we know it's negative, right?
Right.
Okay, function's going down. What do you want to go to next? You like positive numbers or negative?
Positive.
Okay. What number do you like over here?
A 3.
A 3 is good. Positive times?
Positive.
Perfect. That's exactly right. And then, just to make it complete, over here, how about negative 2?
Okay.
That's negative times negative is?
Positive.
And you know what? That's not bad. Going up, going down, going up. And so the local minimum occurs at?
2.
X equals 2. Very good. That's exactly right. Now, if they wanted to know what that was, I sure wouldn't want to plug it in, but we could if we had to, couldn't we? Good job. You did very well. Thank you for calling in. Come back. Happy moving.
Okay.
Yeah, they're remodeling rooms over there, and everybody's got to move. Is that going on at your school, too?
No, it's
No.
not.
My school's having that, too. Who's our next caller?
Our next caller is Antoinette from Lincoln.
Hey, Antoinette. How are you doing? I hear somebody from Lincoln's going to come be on the show as student assistant.
Yes.
Excellent. Do you know who it is?
Yes.
Yeah, that's what I thought, Jaslyn. I was just getting ready to say that. All right, I've got a problem here. Let's find you a really good one. I'm looking for the best problem I've got. Let's do an implicit differentiation. Do you like those?
Yes.
Okay. I'm covering up the bottom because I actually typed 2 problems on 1 page, and that wasn't what I meant to do. So, I want you to find dy dx.
Okay. Then
3y squared
dy dx
dy dx. Thank you for remembering.
plus 2y dy dx
Good. Minus 4 what?
dy dx
Thank you.
minus, I'm sorry, minus
Minus 6x equals
0.
0. I've run out of room, so now I'm moving over. Is that okay?
Yes.
All right. Now, what do I want to keep on the left, and what do I want to ship to the right? Yeah. Ship this one over, and then now we want to add all these up. Okay. Can I put them all together? And then stick on the dy dx. And what's your last step? These are kind of nice, aren't they? They just work the same way.
Yes.
What do I do next?
Divide by 3, 3y squared plus 2y minus 4.
Good. Sometimes they'll give us these on the test and go, show that this is the derivative, and then all you have to do is make it look like their work, right? That's not too bad, is it?
It's really not.
Not really too bad. Hey, thank you guys for calling in. You guys call back.
All right, thank
Okay, bye-bye.
you. Bye.
Who's our next caller?
Our next caller is a mystery.
We've got a mystery caller. Who's out there?
It's me, Hector.
Hey, Hector. What school? Remind me.
What?
Hector from Sunset.
Oh,
Thank-
yeah.
Yeah, what number are you, Hector?
I don't want to show my photo.
You don't want to show? Well, I'm going to look anyway when the show's over, Hector, okay? All right.
Shut up!
They said 15.
Uh-oh, they're telling.
They did.
All right, Hector. You know what? I don't mind if you don't want to show your picture. If you want to work calculus problems, you're welcome to call in.
All right.
All right. Would you tell me what I need to do with this? Oh, and I'm sorry. Let's read the question, right, Hector?
Right.
The dy dx equals xy squared. Y is this when x is 2. What is y when x is 4? What is this problem asking you to do?
Separate, like, what is it called? Differential, separate?
Separate, yes,
Yeah.
it's called differential equation.
There you go.
Or separate the variables.
I knew that.
Excellent, you knew that, of course.
Yeah.
All right, tell me what to write. You might decide to go by the nickname, separate the variables, right?
Right.
You could. Okay, here we go.
XY squared dx.
All right, dy equals, I'm going to leave x with dx. What am I going to do with y squared?
You're going to divide it
That's
on
right.
both sides.
Okay, so now I've got my variables separated. That's step 1. Now, how do you want me to proceed?
Okay, integrate both sides.
Okay. You want me to rewrite this one?
Which one?
This one?
Yeah.
Okay, how do you like to rewrite it?
Y to -2.
That's right. I like to do that. It just keeps me from making mistakes.
Right.
All right, and now, what are you going to do? Integrate, integrate?
Right.
What do you get?
Y to negative 1
Y to the negative 1
divided by negative 1
divided by negative 1 equals?
x squared over 2 plus c.
Good job.
Right.
All right, now can you see where I had earlier, I had an ordered pair. Can you still see it, or is it gone? Let me see if I can find it for you. The ordered pair is when x is 2, y is negative 1/3.
Okay.
So can we rewrite this one, make it look a little better?
Yes.
What could we write?
Negative 1 over y.
Perfect. That is really good. X squared over 2 plus c. And now y is negative 1/3 when x is 2. What can I write?
Okay. Negative 1 over negative 1/3
Okay.
equals.
This is-
What's that other?
X is 2,
Okay. 2 squared over 2.
which is
Oh,
2
4.
squared. No, that's fine. That's good.
Saw 2.
All right. And then, what does this turn out to be?
Oh man, I hate these.
And it's okay. Take a deep breath. What's negative divided by...
Is positive 3.
That, very good. See, you shouldn't hate that. You did it well. And 4 divided by 2?
What?
4 divided by 2?
Oh, it's 2.
Yeah, I don't know why I hesitated. Plus c. What does that make c equal?
1.
Good job. Now let's rewrite it. I'm going to go to here. Negative 1 over y equals x squared over 2 plus 1. And now the next question was, find y when x is 4.
Okay. So you plug in 4 for x.
Okay. Negative 1 over y equals 4 squared over 2 plus 1. What does that give you?
Then negative 1 over y equals 17.
17. Can I put it over 1?
Oh wait,
How much?
It's 9.
Oh, I'm sorry. I didn't hear what you said. So this is 16 over 2 is 8 plus 1. You're correct. I misunderstood. There we go. Keep going.
Okay, so now
I put it over 1 so it'd make it a little easier.
you want do the cross multiplying thing, right?
Yeah. And you know what? You can just do the reciprocal on both sides. You could do, can I multiply by negative 1? And then if I do the reciprocal, what do I get? Y equals?
Y equals 1 over 9.
That's right. Negative 1 over 9. Case closed, right?
Right.
Good job. You did a good job. That's not an easy problem. 2 bells. Thank you, Hector, for calling in. You guys call back, okay? All right. What's going on next week at Skyline? What are y'all celebrating?
We're celebrating Pi Day.
Pi Day. P-I, correct?
Yes, ma'am.
Yeah, baby.
We're having a throw a pie in the face contest. You get to, you have to pay for it. You have to pay $2 to throw a pie at, I believe it's like 4 faculty members.
So you throw pies at the teachers. Now, if I could throw pies at the students, that might be interesting. What do you think?
I think it's so fun.
Y'all are going to have fun. Hey, listen, who's our next caller?
Our next caller is Jessica from Molina.
We should all have pie. Hello? Hey, Melina.
Hello?
Hey, who's out there?
This is Jessica. You forgot to show yourself photo. She was caller number 1. She was photo 36, but I'm photo 18.
Now, say that one more time.
Hello?
You're photo 18.
Yes.
And did we show, is Miss Brzezinski giving me a hard time?
Yes.
I thought I recognized her voice. Jessica, here's your picture. I was going to give Miss Brzezinski a really hard time. Hey, thank you for calling in. Did Miss Brzezinski say we showed a wrong picture?
No, you didn't show the picture of yourself.
Of yourself?
Yeah.
We're going to show it in just a minute. What number is she?
36.
36. Thank you for telling us. We'll get her picture up. Let's do this problem in the meantime, okay? Here we go. dy dx equals, and here comes your cells picture. Yay! Beautiful. That is calculus attitude. Excellent. Thank you. Thank you for telling us that, because we want to show everybody's picture. All right, here we go. dy dx equals 3x squared plus 1 over 2y. Initial condition, y1 is 4. Solve the differential equation.
Okay.
What are you going to do?
I'm going to cross multiply.
All right, tell me what to write.
2y dy equals quantity 3x squared plus 1 dx.
That is lovely. Now what?
And then I'm going to integrate both sides.
Perfect.
That will be 2y squared divided by 2
That is beautiful.
And it's gonna equal to 3x cubed divided by 3
Okay.
plus x plus c.
Our favorite letter, C. Now, do you want to clean it up before we sub in?
Yes.
Okay, tell me what to write.
Y squared equals 3x cubed.
How about just x cubed?
Yes.
Good.
Plus x plus c.
That's a pretty little problem.
Yes.
And now, do you remember the ordered pair?
Yes, it's 1, 4.
Okay, tell me what to write.
4 squared equals 1 cubed 1 plus 1 plus c.
What does that make, C?
It's gonna be 16, 14.
I think you're right. C is 14. And now let's rewrite the problem. Y squared.
Equals x cubed plus x plus 14.
All right, now I want you to solve for y. And tell me how many answers you actually get.
2.
You do. You get y equals what?
Plus or minus
Good job.
x square root x cubed
No problemo.
plus x plus 14.
All right, and how do you know which one you need?
The point, you need to look at the initial condition.
That initial condition, tell me how you're going to decide. 4 is equal to what?
1
1.
cubed plus 1 plus
That's 16.
16.
Is
The
it
square
the-
root of 16 is 5.
That's right. Is it the positive root?
Yes.
Yes, it is. I like the way you checked that initial condition. They used to always make it the positive root, and then one year, guess what?
It was negative.
It was negative. So we have to check our initial condition, and you did a beautiful job of that. Hey, you guys are doing great. What kind of ice cream you got this week?
Oh, we don't know yet.
You don't know yet?
No, but like,
It's just melting? Hurry up and get a spoon, okay?
okay.
All right, thanks for calling in. Bye-bye.
Bye.
Who's our next caller, Gloria?
I believe our next caller is Erica from Carter.
I'm doing very well, thank you very much. So y'all having Pie Day? That sounds like fun, doesn't it?
Say what?
Pie Day?
Nah. We don't
P.I.? No Pie Day? Oh, well.
We don't need no pie.
Holy Skyline. Holy Skyline.
Oh, it's always Skyline. Oh, I get it. Only the Skyline people get Pie Day. We should change that and make it district-wide, shouldn't we?
We need a cake day.
Have a cake day. Yeah, I'm with you. I want to myself. Let me get this where you can see it. Okay, can you see it now? Integral from 4 to k, x to the third dx, it's 0. Find k.
Okay, so first we're going to integrate.
Okay, tell me what to write.
We're going to write x to the 4th over 4. Then evaluate.
Evaluate. I'll write that for you. K and negative 4. Now I'm going to have to go out a little bit so we can see. Okay.
So you're going to put k to the 4th all over 4 minus negative 4 to the 4th all over 4.
I hope somebody has a calculator out there. What does it equal? They said 0, right? Okay.
So it's going to be k to the 4th all over 4 minus 256 over 4.
Good job. Are you just mental math?
Yeah, I'm just mental math.
Excellent. I love that mental math. Now what?
Now you can just, we're going to do k to the 4th. Oh.
What's k to the 4th have to equal?
K to the 4th equals 256.
Yeah, there you go. K to the 4th is 256. So what's k? This is where we need our mental math, don't we?
K equals plus or minus
Good job. Plus or minus
4.
4. That is beautiful. Now let's hold on a minute. Don't hang up, okay?
Okay.
All right. Plus or minus 4. Let's go back to the original. What do you know about x cubed? What does it look like?
John Travolta.
John Travolta, staying alive. I. There you go. If I go from negative 4 to negative 4, how far have I gone?
Nowhere.
Nowhere, 0. If I go from negative 4 to 4, what's happening?
0.
Yeah, it's because it's got that symmetry going on, right?
Yeah.
But you solved it beautifully. Your algebra was perfect. And we can even make it make sense, can't we?
Yeah.
It makes sense to us that you'd get 2 answers. I was kind of wondering, why'd we get 2 answers, right? That's why, because it's an odd function and we got symmetry going on. Beautiful. Excellent job. That's worth 2 or 3 bells and some hand clapping. Hey, thank you for calling in. Good job. Who's our next caller, Gloria?
Our next caller is once again Antoinette from Lincoln.
Hey, Antoinette from Lincoln.
Hi.
How are you?
I'm fine.
Excellent.
Ivante said hello.
Tell Ivante I said hello back. Did he enjoy his gift card?
Yes, he is.
Well, did he buy another CD?
Most likely.
Ivante's the luckiest person I've met in a while, right?
Yes.
I think so. Winning twice. That's really good. So he's letting you call today, huh?
Well, he thought that he couldn't make it because he had a soccer game.
Soccer game. I guess I'll have to forgive him. Did you forgive him? Better yet, did Ms. Etheridge forgive him? All right, let's get you a good old problem. All right, I've got one for you here. We did part of it earlier. Let's see how you like this problem. F of x equals 3x e to the x, and I want the second derivative, and then I want to talk about concave up and down. Did you see the show earlier we did the first derivative?
I think I was trying to call you.
Well, that's okay. You're probably on the phone. Let's go ahead and do a first derivative. Do you know how to do the first derivative? This is 3x times e to the x. What do you get?
Product.
All right, tell me what your product rule is.
First times the derivative.
The first times the derivative of the second. What's the derivative of e to the x? Oh, that's our favorite, isn't it? Plus the second, is that what you said?
Yes.
Times what?
3.
Times 3. Would you like to factor that a little bit and tell me what you get?
Factor of 3.
And an e to the x. And you get what left?
1.
X plus 1. That's right. And we got that earlier as a first derivative, and that's good. And now we would like the second derivative. And so we've got another product rule, haven't we? Okay, tell me what to write again. Let's just take it a step at a time. The first, right? 3e to the x. What's the derivative of this?
1.
That's right. Plus the second. That's what you told me a minute ago, right? And what's the derivative of this?
3.
Yeah, it sure is. And so what do we get when we factor out? What can we factor out? That's right. And tell me what we get when we factor that. What's left?
1.
There you go. That's exactly right. And let's clean that up a little. 3e to the x. And what do we get here? X plus 2. Can you talk a little bit louder? It may be me. Okay? Thank you, hon. That's perfect. All right, now, what do you know about e to the x? E to the x is always what?
Positive.
Very good. And 3e to the x is just, may we say more positive? I don't know. But 3 to the x is just positive as well. So what's the only possible POI?
X equals -2.
Good job. Can I draw a line chart for you? And put -2. Where do you put second derivative on top?
Second derivative on top.
And function on the bottom. Okay? As I go, you want to start over here?
Yes.
This is always positive, so I'm going to put my finger over it. It's not even, we don't even care, do we?
We really don't.
We do not care. If I put, what number do you like?
-7.
Negative, what'd you say, 6?
7.
7. -7 plugged in gives me?
A negative.
Negative. Functions concave.
Down.
Down. Very good. And on this side, what's your favorite number?
1.
1 is a good number. 1 plus 2 is?
Positive.
Positive. Function is concave up. And so you'd write them as sentence. The function is concave up. And what would you say if I wanted concave up? What would you say?
The function is concave
Uh-huh. Tell me the interval.
between -2 and infinity.
Excellent. And remember, don't put a squared off on infinity. They'll go, what? You can get to infinity? Who knew? You must put parentheses when you're doing POIs. I put them anyway, okay? Because if you put a squared off, they'll go, why, they think you can get to infinity, because that's what squared off means, right? You can get there. Hey, good job. That is wonderful. Thank you for calling in. I think we're going to have 5s all around, don't you?
I think so.
I think so. Or is it just the 5s calling in? It's hard to know. Who's our next caller? Hey, Let's see your picture. There you go. you look very serious.
All right.
Are you very serious?
Not really.
Not really.
Wow,
Look serious at the moment. All right, Marco, let's see. I've got a problem here. Do you like integration?
Yeah, I guess.
Excellent. Me too. I like integration.
Whatever.
All right, here we go.
That's right.
The integral from 1 to 5 of 2 minus 3 f of t dt is 20. I want the integral from 1 to 5 of f of t dt. Do you know what I'm asking you to do? It's worded a little different.
Can you refresh my memory?
Yeah, let me refresh your memory. Let's break it into pieces. The integral from 1 to 5 of 2 dt minus 3 integral f of t dt equals 20. Now, this one we don't know. Let me get where you can see it. That'll help, won't it?
Yeah.
All right. This one we don't know, but we know we can pull the 3 out front. That's legal. That's just a scalar multiplier. You can find this, can't you?
Yeah.
Integrate 2. Tell me what you get.
2t.
2t with your plug-ins, right?
Yeah.
Let's go ahead and plug it in. What do you get?
2 times 5 minus 2 times 1.
And what is that?
8.
8 minus 3 times the integral from 1 to 5 of f. I'm just going to say f for shorthand equals 20, okay? All right. Now, could you get 8 over to this side?
Yeah.
What would you get?
Negative 3 integral 1 of 5 and f equals 12.
That's right. Could you divide by negative 3?
Yeah.
And that's going to be the answer you're looking for. What is negative 3 into 12?
Negative 4.
And did you find the integral of f from 1 to 5?
Yeah.
You did. See, you broke it down into something you knew how to do, something you weren't sure of you had to find, and you had 2 pieces of the puzzle filled in. You can solve for the third, can't you?
Oh, yeah.
Hey, you did a good job. They like that problem sometimes. It's a way of checking what you know about integration without just integrating. Thanks for calling in. Who's our next caller?
Our next caller is James from Bryan Adams.
Hey, James. How are y'all doing? Let's also get those boxes loaded up. Yeah? You ready to do a problem?
Yeah.
All right, James, I've got something here for you. It's a little different. Let's see if you like this, okay? Okay, here we go. It's just kind of busy.
Alrighty then.
I've got a function f and g and h. One of these, I want to know which of these could be. One of them has a positive, from what you see, could it have a positive first derivative and a positive second? One of them has a negative first derivative and a positive second, and another one could have a positive first and a negative second. Now, when I use the word could, I get around the problem of, well, what if it goes up and down? But if it's just the way it appears, what is going on? Do you know how to approach this problem?
Hello?
This showed up on the last release test, and I had not seen them do this before, so it was not something I had been teaching. Do you know what to do?
Geometry
Oh, go ahead.
Alright.
Say it again.
Geometry slope.
Go for it. Tell me, you want to check the difference in these numbers?
Yeah.
What do you get? From 10 to 3 is how much?
10 to 3. 10 minus 3, negative 3.
It's just 3. Isn't it going up 3?
Oh.
Okay, so it's going up 3. How much is this one going up?
4.
4? And what about this one?
6. 6.
Yeah, I think it is 6. I typoed on that one. So the first derivative is definitely positive, isn't it? The first rate of change is positive.
Yep.
Let's check the second rate of change. From 3 to 4, what do you get?
Negative, negative 1. It go down.
It did go down?
1, I'm sorry.
It went up. Yeah, very good. And from 4 to 6?
2.
So you have a positive first derivative, a first rate of change, and a positive second rate of change. And so that's this one, A. Okay?
Yeah.
Now let's try the next one. What's the first rate of change?
5.
And the second rate of change?
3.
And the last one?
2.
And the difference in 5 going to 3 is?
2. Negative 2.
Negative 2. Good job. And 3 going to 2 is?
Negative 1.
So this one has a positive what? First?
Yeah. First derivative.
And a negative?
Second derivative.
That's answer C. Okay? And now let's do this one. What's the first rate of change?
Negative 5.
Very good. This is the one decreasing, isn't it?
Negative 4. Oh, Lord. Negative 3.
Good job. And then from negative 5 to negative 4 is a what?
Positive.
Good job. +1 and +1. So this one has a negative first rate of change, but a positive second. I had never seen this kind of question asked on AP, and then all of a sudden it showed up. So we're going to practice on it till we get good, right? You're already good at it, so you may not need to practice anymore. Hey, thank you guys for calling in. I appreciate it. Have a little hand clap, a round of applause, right?
Yes,
We got a round of applause going on here. Who's our next caller?
Our next caller is Jasmine from Carter.
Hey, Jasmine. How are you? You're going to be on the show, right? Is it next week?
Oh, no, I'm not going to be on here.
Oh, you're not?
No.
Well, I think I penciled you in, huh? Oh, maybe that was Mr. Trevino's idea. What do you think? Mr. Trevino has pretty good ideas. Don't you think?
Who is that?
Mr. Trevino? Doesn't he come?
Carter.
You're from Carter. Pardon me, I'm on the wrong page here. My mistake, okay? I'm better now. Are you ready?
Yes.
Here we go, Jasmine. So I probably called you the wrong name. I'm better now. Okay, here we go. We've got the limit is h goes to 0, f of 2 plus h minus f of 2 over h. Do you know what this is talking about is 1? Do you know what that means? That's the limit definition of the what?
The derivative.
That's right. It says the derivative equals 1. That's exactly right. Now let me ask you a question. If a function has a derivative, then it's also what?
Continuous.
Excellent. Okay, here we go. True or false? You ready? The limit as x approaches 2 is 1. Do you know that from this?
Yes.
The limit as x approaches 2?
Oh, no.
No, that's false, isn't it? You know what you told me a minute ago. You know the derivative is 1, okay? Do you know the function is continuous at 2?
Yes.
Yes, you do, because it's differentiable. Good job. Do you know that f prime of 2 is 1?
Yes.
Yes, you do. So what would you answer? Which of the following are true?
Number 2 and 3.
That is perfect. Number 2 and 3. Excellent job. That's exactly right. All of this told you you've got a derivative at 2 is 1. See, they tried to trick you and see if you thought that was the ordered pair, that 2 goes to 1. See, they were trying to trick you there, weren't they? You did a great job. Hey, thank you, Jasmine, for calling in. You guys call back. Bye-bye.
No problem.
Who's our next caller?
Next we have Danilo.
Hey, Danilo. Hi, is it Danilo?
I'm fine. How are you?
I'm fine. How are you guys doing? How are all the BCs?
Hello, everybody.
Oh, yeah, we're doing fine, man.
You're doing well? Gonna make fives?
Yeah, we finished up everything with the,
Perfect. Now you just got to review, right?
excuse me?
Just got to review.
Yeah.
All right, here we go. Can you step back a little from the set?
All right.
All right. Are you calling on a cell phone?
Yeah.
Uh-oh. We'll have to get some feedback here, okay? All right, here we go, Danilo.
All right.
Let h be twice differentiable. That just means you can take a derivative, right? The first derivative is positive. What's the function doing? What's the function doing? If the first derivative is positive, function's going?
It's going up, man.
That's right. If the second derivative is negative, what's that mean? Concave.
It's going down.
There you go. All right, here's what you've got. You've got h of 2 is 10. I'm going to do it like this. 2 goes to 10, and 3 goes to 15. It's a positive first derivative, but a negative second. So it's going up, but it's slowing down. I want to know which of these numbers could be the next value. It's got to be going up, but slowing down. This is 5. So what has this got to be? 16 is perfect. That's exactly right, because the others are too big.
Yeah.
You can't go up more than 5 or you're increasing at an increasing rate. Do you like this problem?
No.
Oh, well, you know what? College Board, AP loved this problem. They put one like it on the last test, yeah. So you're going to love it, aren't you?
Yeah.
There you go. Hey, thank you guys for calling in. You guys call back, okay? Bye-bye. Who's our next caller?
Next we have Brittany from Skyline.
Hey, Brittany. Hi, Brittany. fine. Sounds like you got a room full.
Yeah.
Miss Johnson. All right. Did you say hi to Gloria?
Hey, Gloria.
Hey, Brittany.
I think I'm going to come visit for Pie Day.
You should.
But you wouldn't throw a pie in my face, right?
You come.
You wouldn't throw a pie in my face, though, right? That could be dangerous. All right, oh, wait a minute. We got trouble here in the booth. Here we go. All right. I know who it was. It was Ivan threatening me with a pie. Hey, if it's chocolate, I'm good. All right, here we go. The limit is h goes to 0, tan of pi over 4 plus h minus tan of pi over 4. What am I wanting you to do?
Okay, the first is tangent pi over 4.
The function is tangent of x, right? Which, and then we're going to sub in pi over 4. And so x is going to be pi over 4 in a minute. So what do you need to do? Tell me what to do. I almost said it.
The derivative.
There you go. Take a derivative. That was the answer all fall, wasn't it?
Secant squared x.
Secant squared x is beautiful. And now plug in pi over 4. Secant squared of pi over 4. I wish I knew what the secant of pi over 4 was.
It's 1 over cosine.
Oh, good. 1 over, I like cosine better. Do you? All right. What is the cosine of pi over 4?
It's square root of 2 over 2.
You have that perfectly memorized. Excellent. And now what do you get when you clean it all up? 1 over?
1 over 2 over 4. Then you do the reciprocal, so it'll be 4 over 2, which equals 2.
That is perfect. You did a great job. Somebody taught you some trig, didn't they? We need a round of applause. And oh, here we go. Wow. You like that? I went to a workshop and they said, wow. Which could be, if you turn it upside down, right?
Yeah.
But you did a wow. You did a great job. Thank you for calling. You guys call back.
We are.
What's our next caller?
Next, we have Ruth.
Hi, who's out there? Hello, we got a caller?
Hello?
Hi, who is this?
Hello? This
Yes.
is Mario from Molina High School.
Mario from Molina High School. We'll get your picture, Mario. Mario, I have a picture for you to look at. You ready? Let me get it for you. Oh, you're going to love it.
Okay.
Yeah. I only had room to put 2 choices, right? Now, AP would put 5 choices, but I had room for 2. The function g has this column. G prime, and G double prime are all positive. Which of the following is G?
The one on the left.
The one on the left. Tell me how you know that. You're exactly right. How do you know that? What does this mean? G, G prime, and G double are positive. Translate that for me.
It's above the x-axis.
All right. G is above the x-axis. That takes care of this one. Check.
Yes.
And what else?
And G prime is increasing.
G prime is positive, means the function's increasing. So far, so good. What does G double being positive mean?
It's concave up.
Concave up. Perfect. Tell me about this one. This function is what?
Negative.
Negative below the axis, so G is negative.
Yes.
And what about G prime?
G prime is negative.
G prime is negative. And what about G double prime?
Negative as well.
There you go. So that's the kind of question I like, isn't it? We can translate and choose the one we want. Hey, good job. Let me show you a picture. Is this you? Excellent. Let me get it closer. There we go. Stars here. Hey, thank you for calling me. Good job. Bye.
Yeah,
Next caller, Gloria.
Our next caller is a mystery.
Do we have a mystery caller? Hi, who is this?
Siobhan.
Siobhan from what school?
Carter.
Carter. Hi, Siobhan.
Hi.
I'm glad to talk to you today.
Nice talking to you.
Thank you. Here we go. We got a problem for you.
Okay.
Let's see if I had to zoom out so far a while ago. I may have lost it. There we go. Can you see that?
Yes, ma'am.
Okay. You ready to integrate?
Yes, ma'am.
Okay. Tell me what to write.
Separate them.
Okay. I like that too. E to the 2x dx minus integral to sine of x dx. I like that. That's easier, isn't it, to kind of separate them out and then see what you need to do.
Yes, ma'am.
Okay, tell me what else. What do you want to do now?
I need to bring the 2 in front of the E and bring 1/2 out.
Okay, a 2 in front of the E and bring a half out. That's perfectly all right. I like that way of doing it. Now what?
So 1/2 E to the 2x.
I think that's perfect. Let me double check. E to the U DU needs to be 2. You took care of it. Put a half out front. Beautiful. Keep going.
Mine is
Integral of sine.
cosine 8
Is that all?
plus b.
All right, now let me think a minute. What's the integral of sine?
Negative cosine.
Oh, how's that?
Yes,
Is that better?
Yes, ma'am.
I don't want to make a mistake. Did I get it right? You got it right. Hey, listen, good job. You got your E, you took care of your U sub, and you took care of everything. And you know what? I think you're our last caller for the day.
All right.
Thank you for calling in. Good job. Everybody did a great job. All right, we're going to wrap up. I want to thank you for calling in. I want to thank all of you and my student assistant, Gloria, today did a great job. And I hope that you have a wonderful week. We're going to have 2 lucky winners. How many callers did we have today?
We had 20 callers.
All right, we got 20 callers. We're going to set the screen up and see who the lucky winners are. Thank you, Gloria. Let me get it where you can see. I know everybody like Ms. Brzezinski likes to see. The 2 lucky callers are number 18 and number 1. Who are those winners?
Number 1 is Yesel from Molina, and number 18 is Ruth.
Yourself from Molina and 18 is Ruth. Thank you guys for calling. I hope you have a wonderful week. Keep studying. We'll see you next Thursday. Gloria and I are wishing you a 5 on the AP exam on May the 3rd. Work hard so that you can celebrate when those results come in. Bye-bye.
Hasta la vista, baby.